Awesome. Welcome, everyone. This is another fun and engaging session with Deep Learning Adventures, a fun community with members all around the country and all around the world. I'm joined today by my great colleagues and friends, David and Robert, as well as friends from all around the world. So thank you again. Welcome. If this is your first time or second time, welcome. Want to make sure you feel welcomed. If you joined us in the past, you know that you're in for a treat. So stay back and get ready to have some fun with deploying models on our phones. My name is George. I'm the co-founder and co-organizer of Deep Learning Adventures. And this is the point where I share my screen and talk a little bit about our meetup, so that if you're joining us from YouTube, Kaggle, Meetup, LinkedIn, or different channels, you know where to find us. So again, you can find us on Meetup under Deep Learning Adventures. We've been pretty busy with some Kaggle mini courses. We record all our sessions, and I posted the link on our chat. As you can see here, we've had some interesting sessions on basic data science and data manipulation, etc., data analysis, like pandas, data visualization, SQL, data cleaning, geospatial analysis. We've had some interesting sessions on machine learning as well, traditional approaches, like tree-based approaches. Then we moved to deep learning, like natural language processing and computer vision. Had a fun session with 2 Kaggle data sets and 2 Kaggle competitions that Neil and I presented on flower classification and cassava leaf classification. But a really good session on game AI and reinforcement learning that Dimitri and Alexandra led. I still need to review that myself. And a really fun one where we interviewed Dan, Rachel, and Ryan, who were with Kaggle. 2 of them. Ryan is still with Kaggle, that put together some of the great resources that we've been enjoying recently. Today we'll take a slight turn. We'll be talking a little bit about deploying models on our phones. And just for your context, some of us are part of another group where we are trying to deploy AI models on our phones, on our edge devices. So me, myself, Robert, Steve, Neil, and other members here are meeting weekly. And really our goal is to deploy these AI models on edge devices. So if you want to learn more, we can include you to that group, or you can follow. I just introduced the new channel on our Slack community called Android, IoT, and iOS. Check it out on Slack. And I posted a link for our Slack on the channel as well, in the chat. Cool. So really the goal here for today is use a pre-trained model, use a sample app that the TensorFlow team has built, deploy our model in this app, see what modifications we have to do, and check it out and have some fun. That's really the goal. For this resource, I placed all the links here. We will start with this link here, and let me open it, which is a great tutorial built by the TensorFlow Lite team on how to get started with this exercise. This is minimum effort on our end. You don't need to know Android development, end to end. You just need to know basically how to read the code and where to make the appropriate changes. So it's very easy for you to follow along, similar to other exercises that we've done in the past. So let me place this on the chat in case somebody wants to check it out.
Zoom in a little bit, George.
George, I don't know if you're gonna. Okay, done.
Sorry. Yep. Is this too much? Okay. Cool. So last updated Feb 1st, my birthday. Thank you, TensorFlow Lite team. So TensorFlow, as we've seen, we've used it in the past. We used Keras and TensorFlow in the past. TensorFlow Lite is a model. I think I have a slide here. Let me open it. It's a platform where basically you take a TensorFlow model, you convert it to a TF-Lite format where you apply some specific steps on how to make it in a suitable format so that you can deploy it on either Android, iOS, or NVIDIA devices or other edge devices. There are other optimizations you can do. You can play with how many bits your floats take, like quantization, as it's mentioned here. You can enable or disable GPU when you do deployment on the devices. again, there's a lot of cool things you can do. So there are some examples in this tutorial, like image classification, object detection, or NLP related, like question answering. And some great tutorials as well. We're gonna go with the image classification one today. Cool. Any questions so far before I move on? Either unmute yourself or Robert and David, let me know in the chat.
It's a question, right? Like, so regarding the model conversion, is it like you run some utility on your trained model, or do you need to construct the training itself in a different way?
Yeah, you'll see it. It's a utility that I use in the TensorFlow library. It's very easy for you to convert any model into TF Lite, and that takes care of all the backend and heavy lifting for you. Cool. So we'll build an app that looks like this. You can point it anywhere. You can even point it to yourself and figure out what a TensorFlower you are. That's the terminology I'll be using today. It should be able to capture live stream from your camera. It's sampling at a given rate, we'll see that. And you should be able to detect, the model that we'll build, it detects out of 5 different flowers. It should tell you which one you belong to. Or
only 5?
These are flowers. Yeah, this is a flower classification model. We'll start with that. Later on, we can build more advanced ones, but we'll start with this flower classification one.
Actually, I had a question in the chat, and David wanted me to ask it in person. TensorFlow Lite, is it choosy about the GPUs that it uses, or does it kind of work through most Android phones you can get?
Choosy about the GPU.
Does it only support the GPUs that are available in a certain subset of Android phones, or is it more broadly? I'm not experienced with this, so I'm asking if it's only a subset of Android hardware, or is it most Android hardware?
It's a good question. I imagine there must be a minimum Android version above which it would be.
Well, not just the OS, but also the hardware.
Yeah, that's a good question. I don't know the answer to that. Steve, do you know, or anybody else? Feel free to chime in. I don't know.
I'll try to look it up while you go.
No.
I'd be surprised if it needed anything. I mean, this kind of stuff's been going. They've been supporting things like this for a while. I'd be surprised if it needed anything too elaborate. Also, it's conceivable that it may not even need a GPU at all. If it's just doing inference, maybe it will run in the CPU just a lot slower.
Yeah, the ones that go ahead.
I had a related question, which is what version of Android minimum version is necessary to run this? Because I have an old tablet which won't update beyond Android 7.
Let me do some research and get back to us on Slack. I don't know. That's a good question, though.
Just maybe Steve will find the answer, but I would say probably what's motivating Chris's question is that, on desktop and other types of systems, TensorFlow out of the box only supports NVIDIA GPUs. So
same thing with PyTorch, a bunch of other ones.
Yeah, so it may be similar on Android devices that it only supports a limited number of GPUs. But hopefully Steve will find the answer.
Yeah, and I'm an Apple guy, so I'm sort of over here in Core ML land with Turi Create. That's actually made to use the Intel Iris and other similar video cards in Apple hardware.
Oh, to see which operators are available, looks like there is operator compatibility. Oh no, these are for the TensorFlow operators. Got it. Not for the hardware operators.
Yeah, George, but I just checked. So there's a similar list for TensorFlow Lite for compatibility list. You just have to have Android 8 or later. And to the other point, none of the GPUs on phones are NVIDIA. So I think they all work to an open standard. I think it's OpenCL.
Oh, nice.
Yeah. So it's on the website, but
there's an iOS quick start as well for you, Chris.
yes.
I'm hoping we can cover this in another session. Cool. All right. So that was the general overview. Let's zoom in a little bit in the next step. So we'll be using Colab to use what is called to do a transfer learning. We'll be using a pre-trained model on a larger data set, and we'll be fine-tuning it a little bit. But for the purpose of this demo, this exercise, really what we need is two things. One is the train model that we'll be storing it as model.tf Lite, as well as just a simple txt file with one row per label called labels.txt, and we'll see how that looks like. So this tutorial here redirects us to this this Colab, which we'll take a look together. Let me zoom in a little bit. So we're importing TensorFlow, making sure we have, at least 2.0 something version. We have a location, Google storage location where some sample flowers are used. This is used for fine-tuning of our original model. We'll be downloading that tar.gz file here and storing it locally as flower photos folder. We'll be creating what is called an image data generator in TensorFlow. The image size is 224 by 224. We'll be using a batch size of 64 images at a time. And we'll be converting the pixels from 0 to 1. That's why we're dividing by 255 here, which is the range of RGB. And we'll be, out of all the images, and let's see how many images we have, we'll be splitting them into 80-20% training and validation set. So looks like we have about 3,000 here, or 4,000. About 3,000 of them will be in the training set and another 700 in the test set. For the training data generator, we'll be using the 224 by 224 image size. The batch size is 64 again. And this will be our training set. For the validation one, the exact same one, this will be our validation set. And just to make sure we have the right dimensions here, we're just plotting the batch size, which is 64, the label, the image batch shape, and the label batch shape, which is 224. Sorry, image batch shape is how many images we have in one batch, 64, and what is the size of each image is 224 by 224 width and height, and 3 pixels and 3 channels for RGB. And the labels is just 64 images or labels we have in one batch, and it can take values from 1 to 5. So it's looks like it's one hot encoded. We'll be using the labels for later, so we're just storing them here as a text file. As you can see here, labels.txt, but really the labels are 0 for daisy, a specific type flower, dandelion, roses, sunflowers, and tulips. So we'll be limiting ourselves a little bit in these 5 classes. Later on, we can explore, more advanced cases, like in the session we had together where we explored over 100 different types of flowers. But if we follow this paradigm, hopefully it's just as simple as updating the model and updating the labels.txt, and ideally everything else should work the same. It's just a larger model. Cool. So that's one of the inputs for our exercise here, this labels.txt, and this is how it looks like. For the model part, we'll be using a pre-trained model on ImageNet called MobileNet v2. And again, if you were in the Pedals to the Metal session, I did a thorough examination or a thorough experimentation of different models, and MobileNet was one of the lightest one that has a decent performance in terms of classifying the 100+ types of classes and flowers. So we'll be using it from the TF-Keras applications API. We'll be importing MobileNet v2. The input shape will be, again, 224 by 3. We don't need the top part, which is the classifier part. So that's why this is false. And the weights, we need them initialized from ImageNet, the larger data set of over 1.4 million images and 1,000 classes of web images. So that takes a few seconds to download. This we call the base model. We're not going to train this. And then we'll build our own overall architecture with a base model, as adding on top of it a 2D convolutional layer with 32 filters, Gradle activation function, a dropout, a global average pooling that takes us from a 2D or 3D dimension to just one long single vector, and then a dense layer in the end with 5 classes, simply because we have 5 classes in our example here. That's as well as softmax. So we know to pick the one that has the highest activation.
George, did you design this, or did this was part of their?
This was part of their notebook.
Okay, I'm just a little. I find it unusual that they add another convolutionary layer on top of a pre-trained model. But they must have found better performance with it or something.
Yeah. Yeah, maybe we can comment it out and try how that works. Yeah, and the one that we're working from Kaggle, I usually worked with a global average pooling one and a dense one, maybe a dropout, but yeah.
Yeah,
I didn't usually come to the.
Why average instead of max pooling?
I think I used both in my other example. I think this one performed slightly better. But I don't have a.
That's not average pooling, that's the global average pooling.
Yeah, this is taking you from the 2D world into one long vector. So this is like basically like instead of flattening it, you're doing also this average operation. Cool. So for compiling this model, we're going to use the atom optimizer here, categorical cross entropy, because we have 5 distinct classes. We'll be plotting just the accuracy, but the loss we'll be monitoring is categorical cross entropy. In terms of parameters, most of them are in this base model, about 2 million parameters. The conv2D has about 300,000 parameters. The dropout none, the average pooling none. The dense has about 165. So out of 2.6 million parameters, only about 300K, which is the conv2D, and the dense one are trainable.
Just another question regarding that average pooling versus max pooling. Do you know what for the data set that we're looking at, do you know if the flowers are encompassing most of the field of view in most of the examples, or are there varying sizes? There's some images that contain only a small number of pixels allocated to the flowers.
Some have multiple flowers.
Because it seems like the question of average versus max pooling, we have such a small number of pixels left. Maybe we're more likely to use average pooling in this case. With such a small number of pixels, it's like many of the remaining pixels have had some access to the flower portion of the image.
No, I did not do any kind of like EDA like I did for the Kaggle dataset one. So I don't know how rich or how diverse the training set is. But that's a good question though. We can quickly take a sneak peek. I just downloaded this star.gz file. If I can find it. I create a new folder. All right. Somebody asked for flowers. Oh, sorry.
It's almost Valentine's Day.
Just flowers you will get. All right, Daisy. Looks like close up to me. Sorry, let me make this a little bit bigger for us. Very close.
Overlap there too.
Yeah. Pretty in frame, I would say, and close, I would say. roses. All right. Different colors.
Yeah, some of them are cropped out too.
Sunflowers. Oh, this is beautiful. This is more further out. I like where this event is going. Beautiful. Oh, with other things in the background. Okay.
Mm-hmm.
That'll be interesting to classify.
Well, I mean, it looks like there are some examples where the flowers take up a very small fraction of the image.
Yeah. Cool. Thanks for the question, Robert. I didn't think to go that bad. I'm glad we did. All right. So this is our model that we'll be doing fine tuning. We'll be training it just for 10 epochs and again, monitoring that cross entropy loss. Just looking at some training curves. This is accuracy. Blue is the training one. As you can see, we're kind of overfitting here after a few epochs. And orange is the validation accuracy on the validation set. So after a few epochs, you see the gap is it's growing more and more. So we're definitely picking nuances in the training set, but not generalizing enough so that we do better in the validation set. Same with the loss. You see that after one or two epochs, we're diverging. Another experiment that the Colab here did was, okay, why don't you just continue training the base model as well? And then we tried this in our Kaggle example as well, and this performed relatively better for us. So not only that, but you can actually figure out how deep to go in the base model. So this MobileNet v4 has 154 different layers. We decided to freeze the first 100 and fine tune anything after that. So anything until the 100th layer is not trainable, and from 100th to 154th is trainable. Atom classifier, the only difference is just a small initial learning rate. Now remember, we unfroze about 50 layers of MobileNet, so the trainable parameters just spiked. In the past, we just had 300K training parameters. Now we have 2.2 million out of 2.6 million. Let's train this for maybe just 5 epochs. And what happened to my graph? I didn't show it. Maybe you can see it here. So we kind of staying at that 80 plus validation accuracy, 84, 83, 83, 84, 83. So it helped a little bit, I think, but not a lot. Let's see again, what was it here?
What's the difference between the trainable variables and trainable parameters? Here, like this in Labo.
Sorry.
It says 58 here, right? Trainable variables. But in the trainable parameters, it's about 2.2.
Yeah.
million.
I think it is somehow related. It's not a one-to-one mapping to the layers, but I think it's how internally this model has stored these weights and biases. So I think it's a collection of weights and biases in different layers. I think I have it printed out somewhere, but I don't see it here. So before, when we just froze the entire model, we just had 4 trainable variables. Now we have more, simply because we have more layers. But maybe I can do a printout in the very beginning so you can see how this.
It looks like it's at least linearly related to the number of trainable layers.
Yeah. I'll start it running so that by the time I go to the end, maybe we can revisit this. There you go. There you go. Oops, sorry. So we have for each layer, in this case, the conv2d. Probably start weights for the conv2d, and then conv2d bias, and then the dense, and then the bias. So that's just 4. And then probably for the other one, you have way more because we unfroze so many layers from the MobileNet v2.
Yeah, probably about half of them are convolutional layers with weights and biases, and the other half are pooling layers with no parameters.
Yeah, let's check it out. I think this is training though, so it might take a few seconds. Yeah. Okay, I'll let it run. I don't want to spend too much time here because we've seen this in the past, but yeah, I'll start it for us. Cool. So where the edge part starts is we have a model now. What do we do with it? So this is where this TF Lite format comes into the picture. We need to define a folder where we'll be storing our model, and we use TF save model save. This converts it into a format that is you can reuse later on. And then from TensorFlow, there's a Lite library and a TF Lite converter module that uses this method from save model, just uses the path that you save your model. Then you called that object convert, and that just converts it for you to a TF Lite model. You just write that as model.something, model.tf Lite to be useful, and then just writes it for you, and you have your model.
Is TF Lite a standard extension for that?
Yeah.
How big is that model, out of curiosity?
I think it's about 10 megabytes. Yeah, 10.3 megabytes.
Hmm.
Cool. This is using those 50 plus layers that were trainable. So again, overfitting a lot. I don't know if we really gained any improvement there. So the summary is we use a pre-trained model. We fine-tuned a little bit after that, but really all we want to get out of this exercise is saved model as well as the labels. Oh, sorry. TensorFlow just gave us our answers. And this is all really what you need to go to the next step. So we can go back here, zoom out a little bit. So we're done with our Colab part. The next thing we'll be doing is downloading this GitHub repository, which has already pre-built examples with TensorFlow Lite. So it's just a GitHub repository under TensorFlow examples.git. We'll be using the examples subfolder. And this is where things get interesting, because I'll show you how that examples looks like. So the examples has Lite, Colabs. Looks like there are two examples to begin with: a digital classifier or a digit classifier and a flower classification. There's Android. When you're doing this, you want to start here under start. Finishes the completed example. If for some reason you just want to go to the completed one, you can go there. And then app, source, main. Assets is where you want to copy your labels and model. And everywhere else is probably where the code is. And we'll be looking at this code together. For Android users like myself, I'll be using this Android Studio. You can download it. Let me open it for us. For iOS developers, you need Xcode.
Yeah, Xcode, and the process is broadly similar. Xcode is the environment that works roughly the same way, to where you get source code and you get references to files that are going to be copied into something called the app bundle, which I'm assuming is the same thing with Android. It's a folder that looks like an executable file that contains the assets and the actual executable and some other stuff that is used when the app runs, which is where the model is going to go. And if you have any other sort of preloaded config files, that's where they can go to. I do this for a living, so I can speak to it.
Awesome. Maybe you can give us an iOS demo next time, Chris.
I'd be happy to.
Cool.
Actually have what I've been playing with for tomato leaf diseases.
Nice. Awesome. So for this, sorry, was there a question? Somebody unmuted themselves?
Does Android Studio come with a simulator?
Sorry, I didn't hear you. Do you mind saying it again?
The Android Studio, right? Does it come with a simulator? There are even after you compile, run the project without that.
Oh, unfortunately, I couldn't hear you. I heard Android Studio. If the question is, what about other platforms? Is that a question? If you don't mind chatting and texting in the chat, that'd be helpful. Sorry.
Yeah, along with Android Studio, you're going to have to download at least one emulator so that you can do some very rough testing before you try it on a device. Yes, it does.
Oh,
It
okay.
comes with your choice of emulators, and they map to multiple different kinds of Android models.
Yep, we'll see them. Yep, you don't need an actual device. You can actually simulate one. Yep, or emulate one. So again, when you open Android Studio, you want to import or
Actually, I think the one that's at number 8, because I was skimming through it before, I think it's just something that don't run this on an emulator because it'll crash.
You can run an emulator. I think it'll work. Yeah, I haven't tried it personally, but I've run other projects in emulators and they work fine.
Yeah, it's one of those it depends kind of things, because if you're making the calls to hardware that doesn't exist on your PC or your laptop or your Mac, then it has crashed before. I mean, not for me, but for people on the Android team where I work. And David, yes, you write it in Swift or you can write it in Objective-C. They both work on Xcode, and Xcode also brings in a simulator. But if you're going to do this kind of stuff, you really need to have a device so that you can get a live image, or you can store sort of pre-built images in the simulator where you have to go get it off a camera roll. Like I said, not the next meeting, which might be on a Friday, but in a month or so, I'd be happy to put together a session on this for iOS if you want.
Perfect. So we open Android Studio here. We point it to an existing project under example slide, Colab's flower classification, Android start, and that will import the existing project that we downloaded from GitHub to Android Studio.
Can you zoom in a bit? Okay, thanks.
Sorry. Yes, I can.
Thank you.
Then the other thing we have to do is navigate to Android start app source main assets, like I think I showed you here before, and copy the label.txt and the model.tf Lite that we exported from our Colab session. And then really the next few sessions of this tutorial are doing some slight code changes. There are some parts here in the code where we have to add, for example, some dependencies for TF Lite or GPU support, and we do those in this build.gradle. So let me look at the code for us. So under start app build.gradle, and I need to figure out how to zoom in a little bit for you. Zoom. Not in zoom. Not sure how you zoom here. Window, edit, maybe. Maybe I can paste this somewhere else. Well, this is the part where the code change that we're doing for this part. That's number 1. And then under Android, we added this compression notifying the app that we'll be using a TF Lite as an input format. Awesome. The next step is initializing the interpreter. We do that in this classifier mobilenet.java. So let's take a look at that. So here we have.
It's an interpreter?
Yeah, this is like Java based. So we're extending an existing class. Yeah, I'm sorry. Let me copy this actually here, so that you can see it and save this as downloads something dot Java. There you go. Okay, now I can zoom. Perfect. So let's figure out the part that. So there are two changes we have to do. One is this get model path. We have to specify what is the model name, and we named it model.tf Lite.
Yeah.
As well as the labels, labels.txt, so that the app knows where to find them. I think that's the only change we did here. Yeah.
Yeah, and if you had a model by a different name, you'd have to go ahead and replace that return model.tf Lite with whatever you called it.
Yeah, yeah.
Flowers.tf Lite or cannabis.tf Lite or whatever it is you're classifying.
Exactly, yeah. Cool. Yep, right here. Then in the classifier.java model, let's go there. This is another file. This is the longest one probably. We are looking at how do you declare a TF Lite interpreter. So let's look at our to-do. So you have the option here to either use CPU or GPU. Let me copy this on our another session. All right. So interpreter is TF Lite. I used CPU for this. I haven't done the GPU part yet, so you do it probably here. So creating an interpreter, that's I think the next step that we did. Sorry, I don't want to go to inference yet. Let me see what else do we do after this. So that's the classifier interpreter. And just making sure that we close the interpreter when we are done. I think that's the only part here. There are other settings you can specify here. I didn't play around with any of them. So just the very basic setup here. Cool. Now how to do an inference, that's the interesting part. So there is a pre-processing step that we have to do in our images. And let's see how that looks like. We have to load the image. We have to do some kind of resizing it or padding it.
It's always the same set of operations.
Yeah, so it looks like it, right? So you're resizing it based on this crop size and image size. You are normalizing it, probably dividing by 255, and then you are giving it to the next step.
Okay.
Yeah.
Pipeline.
And then, so let's look at in the code, right? In the code, this is again the same file. So load image is the method that gives us a buffer.
Where are you getting the image from? The camera or the camera or the gallery?
So load images here. Image buffer load probably from the camera. I would imagine. I think so. I mean, I've used it, so I know it's from the camera. I just don't see it here in the code clearly. Image buffer, tensor image. Okay. Tensor image data type. Okay. So somehow we're getting the image here.
It's not that important.
It's probably somewhere else. It's definitely not here.
Yeah.
But probably this is the input of the model, right? It's probably other libraries they use to capture. The
Yeah,
image.
there will be a lot of them.
Yeah, I can imagine. To do. Oh, I wanted to see that label probabilities because that's how we call the model. Okay.
You have flowers in your apartment?
We'll get there. Builder. So I wanted to show you when you call the model and you get a list of probabilities. There you go. At the end of the day, you can choose how many you want. This top K. So this output probability buffer. Let's see how we got it.
So out of 5, it'll be the top 2 or 3 with the highest probabilities.
Yeah. So I think we fixed it to 5. Let's just confirm.
Yeah, I'm pretty sure it was 5 total classes that you were actually training the head on.
Yeah, max results. Max results is probably 3. It's
Okay, cool.
3.
The top 3
out of 5. All right.
Instead of flowers, I go for prime rib, Robert. Slow roasted for 3 hours.
Cool. All right. Now the interesting part. So you save this project, this classifier.java updated file, and this mobilenet Java updated file, the build process. So this is where you can choose an actual device, or we can choose an emulator. And let me show you real quick where you do that. So right now mine just has what is called a simulated manager, or this Android Virtual Device Manager, AVD Manager. And in here you can add a virtual device. Say for some reason you want a specific Pixel phone, Pixel 4, Pixel 3, Pixel 2. You can do it on Android TV, phone, Samsung, Nexus, Android Wear. If maybe a watch, you can simulate a watch, tablet, automotive. Let's pick one at random. Let's pick this one right now. Or you can also choose which one and maybe the size.
Mm-hmm.
You can specify what Android version or you want to support. So this is the oldest one. Nougat, Oreo, Pi, QR to the latest one. There's Android 11, 10, 9, 8, 7. So it looks like 7 is the lowest we can go. Let's pick the latest one. System image. Okay, there's a lot here of options here. I didn't go with this option. I connected my phone with a USB, not with this one, sorry. So USB on my computer and this USB-C on the phone, and that's where I was able to detect it. I had some hiccups, so I'd like to talk about the hiccups of when you do this, you might run into them as well. But this tutorial really guides you of, I want to simulate maybe a specific device or a specific tablet. You can do that as well. All right. So the main one is your Android Studio is not detecting your mobile device. That's the main issue. And there are a few things you can do. The number one is when you go to Android Studio under Tools, SDK Manager, SDK, Android SDK here, there are some libraries they need to install. So let's check it out. Tools, SDK Manager, Android SDK. So I was missing, for me, it didn't work because I was missing, I think the latest one, 11 Android here, support from Android Studio. As well as maybe Android SDK tools for me was not there. So one of these was missing for me. And once I clicked on them and apply, it will actually download it for you and install it. The emulator for me was there, but I didn't want to use the emulator. I want to use the real device. I had to plug and unplug the device. It wasn't automatic. Let's see, anything else I tried here? I don't think so. Those were the main reasons. Some other people, some other users online were saying that maybe you need a different cable, this and that. I was hoping not to because I didn't have another cable. But yeah, that took me a little bit of a few minutes to figure it out. Oh, and sorry, the other thing that's very important is in your phone, this won't work unless you go to your advanced settings in your phone. So that's the setting on the computer side. Now on your phone, you have to what is called enable USB debugging. Basically, you have to give permission to your computer to access your phone as a USB device. So first of all, to do that on Android devices, you have to go to System Settings, and you have to hit, I think, an option like you have to tap it 7 times. That will not unlock the phone, but enable your developer mode feature. And then there's an option where you can enable USB debugging as well. Once you do that, you're basically able to access your phone as a USB device.
Yeah, and the reason it does that is so that you can actually send information back and forth between Android Studio and your device, which it's locked out normally for privacy and security reasons.
Yeah. So you need both of them on both ends.
Yeah, put something in the chat. So if anybody's interested in mobile development, either Android or iOS, there's a website called raywenderlich.com that is a really good source of tutorials for all of this. So if this is going a bit fast for you, you can kind of go there and fill in the blanks.
Cool. Yeah, this is by no means a detailed explanation. This is just us. I'm just following this example, and I've worked with Android Studio in the past, so I'm a little bit familiar, but by no means an expert. Then the last thing is building this project, and if you go under this Gradle sync option and hit play or this build and select your device, it will actually deploy it on your device. The last thing you'll see is when you open the app, it will ask you for permissions. So it'll ask you, can you record video or can you also access your files as well? And then it will look like something like that. Let me get TensorFlow here. Let me pause here so that I can show you how that looks on my end.
It's either for Android, it's either Java or Kotlin. There's something called Kiva that will let you do Python for mobile development, but I don't know how actively it's developed.
Yeah, I'll stop here. I'll stop sharing. I will start sharing on when the host can share this meeting. Why? Oh, share screen. Sorry.
And there used to be, or may still be, a project called RubyWax that will let you do Ruby inside kind of a shell. Oh, nice.
Ooh.
Let's see it. Yes.
All right.
No flowers there.
Hold on. I just want to see the layout. So can you see my screen?
You're an Apple. I think it's Tulips.
Okay. Yeah. So the layout is, remember we had that top K? That is the 3 classes. So tulips, daisy, roses, sunflowers. This is the frame we're looking at, 640 by 480. we're cropping it at 224 by 224. Remember when we were training the model?
Is it looking at the mouse pad?
I'm just
You
explaining.
got flowers on your mouse pad?
Sorry, Chris, can you give me a second? I'm just explaining the layout first.
Sorry.
So the model that we trained was a 224 by 224. That's why we're doing this. Rotation 90. I think that was a 90-degree rotation that we did. This is a good inference time of what is the latency of when we do inference, right? So it takes about 60 or 70 milliseconds to actually do an inference. I didn't play around with these threads, and if you see under CPU, I only have CPU, I don't have another GPU. So let's check it out. I have some sample flowers for us here. I have like a toy one. This is a toy one. So let's see what it says. I think it says tulips or roses. Roses. This is a fake flower, but I also have a real flower here with us.
What's on the mouse pad?
It's a flower.
Nice. That's what it was.
It's, I don't know what kind of flower it is. That's a design, but let's go to, this is the famous flower. And if you're following on Instagram, this is my birthday flower that I have on in my kitchen. So this is a daisy, this is a variation of a daisy. So if I go closer, 100%, 99, maybe if I show more leaves.
Yeah, from an angle, it's not quite so sure.
It switches, right? Because it doesn't see the flowers. Let's move around a little bit. Maybe different angles. Daisy. Still daisy. Are we still a daisy one? Yep, still daisy. So it's pretty convinced that it's a daisy one. This one, I don't know. This looks like daisy to me.
What if you pointed at your face?
Yeah, I did. So let's check it out.
Roses.
Tulips today. I'm tulips today.
Nice. Well, you do have two lips.
When I was wearing red, so let me show you when I was wearing red. I'm still tulips? Huh, I was red when I was wearing this the other day. And let me show you my guinea pigs. Guinea pigs, what tensor flowers are you? The QB is something between Dandelion and butters. Roses or sunflower? Hey, Rose. All right.
That is cool.
Let me stop sharing.
Oh,
yeah. And again,
There's a question in the chat.
Example.
I missed it.
There was a question in the chat. If you pointed it at a digital picture, just a picture of a flower, would it?
Yeah, exactly. Let me do that for us.
He did his mouse pad.
That was a drawing, not an actual photo.
Yeah.
Oh,
okay. Yeah. So sorry.
Splitting hairs.
No, you're right, because in the presentation I have. Sorry, I have to admit myself. Can somebody admit me? Okay. Security, share screen. So I tried this with different ones. So we had what? Roses, right? Roses is one category. Dandelion was another one. Daisy was another one.
Sunflower.
Sunflower was another one. Thank you. And what was the fifth one?
Tulip, I think you didn't say it.
Tulips. There you go. Perfect memory. So I'm just opening some tulips. Images. Okay. Let me share my screen again. Okay. Sorry, I wanna go here. All right. Where are we? That's a pretty blown up picture. So let's maybe look at the smaller ones. So I just Googled roses. So this better be all roses. This one switch between tulips and roses, 50-50%. Let's pick a rose that is not red.
What are the yellow? The yellow one went to sunflowers. Try that yellow one there.
Is one here in the middle? Yeah. Is one here?
No, not now. It's roses. Yeah, good.
Let's pick one with another variety. Yeah, because I think the variety confuses it. The color. See this? Roses, tulips, roses, tulips. Okay, that's roses. Let's look at Dandelion.
Yeah, part of it's because you have so many of them there.
Dandelion. Well, I'm focusing, right? So 80% Dandelion. I don't think I've seen a yellow Dandelion. Is that yellow? I thought it was all white.
Dandelion.
Dandelion. Oh,
Dandelion, yeah.
How we always say it.
is that what it was?
Dandelions are yellow, and then the white is when their
Ah,
flowers are all coming in.
thank you. Thank you. I didn't know that. This is sunflowers, it thinks. All right, let's look at some daisies. 91%. 90%. Let's pick one where daisies are mixed with other things. How about this? What is this?
Yeah, it's kind of interesting watching the probability change so much when you're sitting on the same image.
This thinks it's a sunflower.
Well, it isn't sure. It's got.
Yeah, right.
Yeah, it's not sure because it maps those features to quite a number of things, and they can't pick one of them out of the whole assembly of things. So focal attention or some mechanism to simulate it would help that a lot.
Sunflowers usually show up on their own. Is that why it's so easy for them to be detected? Let's pick one where they're not on their own. Oops, I didn't want to click on you. Oh, that's an ad. Maybe this one. Let's find one where sunflowers are with other. A bouquet of sunflowers, maybe. That's what I need to find. Maybe this one where there's a person. Oh, interesting. Look at that.
Mm-hmm.
I think it's a tulip. All right, and let's actually look at tulips.
Well, yeah, because you're mapping features into 5 categories, and so it's sort of limited as to what it can actually decide on.
Yep. Some tulips, some tulips. This one, I don't know what's gonna. Oh, I'm surprised. Sunflowers. Oh, interesting.
Yeah.
Not used to seeing the tulips so open.
Oh, you think so? This is an interesting
Yeah.
case. Or is it because they're black? Maybe I think maybe the black part of the.
No, I think look how the flowers are opened up. I don't think it.
Yeah, the petals are a lot more sunflower-like than they are tulip-like, at least in terms of how I'm usually used to seeing them. They're sort of cup-like in most photographs I've seen.
Sorry, this is tulips, right? So it's right.
Oh, try a Venus flytrap.
I have no idea what is that. Is that the type of flower?
Yeah, it eats flies literally.
Any other flower you want me to try, 9s or 10s?
Marigold.
Marigold.
I would probably think those are dandelions. I bet.
How do you spell that?
M-A-R-I-G-O-L-D.
Marigold. Is it this one?
Really?
I think it's a tulip.
Try yellow marigolds.
Is it because it's orange?
Yeah, try the yellow ones. I'm thinking that it's going to think those are.
Oh, those are beautiful. My. Oof.
All over the place. Sunflower.
I thought it would be deciding between sunflowers and dandelions.
Or roses.
Well,
If
yeah,
I
but
zoom in, if I zoom in,
but look at those. Look at the probabilities down there.
if you zoom in,
they've actually gone down to where there's none of them have a majority.
I think if you zoom in, it thinks it's roses. If you zoom out, it keeps switching between sunflowers and tulips. Let's pick another one, maybe with other colors.
I wonder, would it be that confused if it's just one flower in the picture instead of a bunch?
I think it's getting confused here.
Because it might be that the flowers sort of overlaying each other makes it look like
That's what I
something
think
different.
it's roses. Yeah.
All right, last request, specific flower. Cactus? No, that's not a flower. Let me see what happens when I play around with the CPU threads. I didn't play with that before. I was hoping the inference time would be slower, but it's actually taking way longer. Wow, almost half a second. Right. Is that like a communication bottleneck? Yeah, with one CPU, it's less than 100 milliseconds. Cool. Let me find the friends. All right, perfect. Let me close the file. That was a fun adventure in the world of flowers. Again, this is like a very soft introduction to deploying a model on your phone. So I appreciate all the great questions. We'll try and answer them in the best way we can. But again, this pretty sure we can find, Chris, thank you for your help. Pretty sure we can find also some answers online in terms of how these things work on your device or your emulator. That's what I had in terms of demoing. Let me show you what is coming up, and then I'll just open the floor for discussion. Cool. So hope you enjoyed this session, friends. And again, this was something that is relatively easy to do. I think the only challenges are maybe with Android Studio, or if you want to do this in iOS, maybe we can do another session in the future. But really just having those packages in Android Studio installed and making sure that you have the version of Android that your phone is supporting. And that's very useful as well, or needed. We have 2 more sessions coming up. Robert is leading a cool pedals to the metal, not petals to the metal with a D. And he's taking us for a deep learning day trip with his bike adventure next Wednesday. And the famous space adventure is coming up as well, hopefully by end of February. I'll try my best not to postpone it again. And that should wrap up our Kaggle adventure. And then we'll be taking a deeper dive into this data and deployment specialization that I have a link here. I'll share this on the chat. But if you want to prepare for more Android and more flowers and more deployment, please take this specialization. We'll be using TensorFlow.js and TensorFlow Lite to build models on different devices. A few of us have taken it. I haven't taken it. David, I know you've taken it. So I've heard good reviews and good things. I've heard that it's a little bit challenging. So looking forward to that.
Good to do it with others.
Yeah. Cool.
Will each course in the specialization be 1 week? Or will each week be like a couple modules within a course? Just say if we wanted to catch up.
Yeah, usually what we've done is usually the first course, well, we need to take a look, but usually the first course is kind of doable. I don't know, David, but usually we've done like maybe a couple of weeks worth of Coursera material in one session of ours. So it took us about what, 3 months? 3 months.
But this one covers a lot in some of the ones. So, but yeah, some of them we might be able to squeeze a couple together. Yeah.
So we'll do it by complexity level, I would say. I don't think we have a golden rule, but we'll do it by complexity. If, like an hour and a half, how many models or how many can we squeeze in? And really, the goal is for us to have done it, tried it on our own in advance, and then coming here and discussing questions and feedback. So that's why I highly encourage you to check it out now, so that when we start in March, you should be maybe first, second. If you're on the second course out of 4, that's great. So that you're a bit ahead, and we'll be starting maybe 2 weeks a session, so we'll be moving a little bit quickly, I'd say.
That's helpful. Thank you.
Yep, anytime. Cool. Anything else? Comments, questions relating to this session before I stop the recording and open up for discussion? Okay, I'll stop the recording here for the YouTube folks, and I'll leave the floor open for discussion, friends. Thank you.